Nice to see everyone again. And for this video, we are going to talk about topic 1, Introduction to Organic Chemistry. It's a very long topic that has 6 subtopics. First, we have Introduction. And then we have 1.2 Structural Formula. We have 1.3 Classification of Organic Compound. We have 1.4 Hydrocarbon. We have 1.5 Isomerism. We have 1.6 Basic Reaction in Organic Compound. And for today's video, we will focus on Introduction. Very short video for today. In Introduction, we will be looking into on how to identify the element that made up organic compound. So what element that we are going to talk about, or what element that you always come across, like carbon, you can come across hydrogen, you always come across oxygen, nitrogen, sulfur, chlorine, and so on. These are the elements that we always come across in organic compound. For example, if I'm having methane, a very simple organic compound that you have CH4. So a methane looks something like this, a CH4 in the form of tetrahedral. If you remember in your molecular geometry, that is your tetrahedral. So in this methane, what element made up methane? You can see over here, we have the presence of carbon and then we have the presence of hydrogen. So carbon and hydrogen is the element that made up methane. Alright, simple. That is how we identify the element in an organic compound. We have a few organic compounds that we are going to look into. First, we'll look into urea. So what is urea? Urea is a white crystalline solid. And the structural formula of urea looks something like this. From the structural formula, you can see that in urea, we have the presence of hydrogen. We have the presence of nitrogen. We have the presence of carbon. We also have the presence of oxygen. So how many elements made up urea? We have 4 elements, which is hydrogen, nitrogen, carbon, and oxygen are the elements in urea. Next, we have glucose. So what element made up glucose? Let's look at the structural formula. In the structural formula of glucose, as you can see over here, this is actually a carbon. This corner is actually a carbon. Every corner of a line is actually representing a carbon. That is the skeletal structure that we will look into in your 1.2 later on. But before that, we go back to the element that made up glucose. So obviously, in the glucose, carbon is one of the major elements. You can see over here, we have a lot of carbon. And as you can see, we have a lot of oxygen as well. So in the glucose, oxygen is one of the elements. Last but not least, we have the presence of hydrogen. So in glucose, we have 3 elements, which is carbon, oxygen, and hydrogen. Next, we have the presence of penicillin. Penicillin is a type of antibiotic that we always use in our pharmaceutical. And the structural formula of penicillin as an antibiotic looks something like this. As I said just now, every corner of this is actually a carbon that we are going to learn in your 1.2 skeletal structure. And we know that every carbon deserves 4 bonds. So as you can see, every carbon over here only having 3 bonds. So one more is actually your hydrogen. So this carbon is actually holding a hydrogen. That is a complete structure if we are expanding it. Same thing over here is actually a carbon holding a hydrogen, a carbon holding a hydrogen. Bear that in mind, every carbon in this world must have 4 bonds. No matter it's single, double, or triple, it must total of 4 bonds. So in penicillin, you can see over here, what element made up this antibiotic? First and foremost, carbon. You can see carbon is the one that making up this antibiotic. Other than carbon, we have the presence of Cl, which is your chlorine. So chlorine is one of the elements in your penicillin. Next, we have the presence of hydrogen. As you can see over here, the next element is your hydrogen. Other than these three, what else we are having? Nothing. We don't have oxygen, we don't have nitrogen or so. We only have carbon, chlorine, and hydrogen, as you can see from the structural formula. That are the elements that making up penicillin antibiotic. Next, we have cigarettes. What is in the cigarettes is the tobacco. So in the tobacco, we have the presence of nicotine. And the structural formula of nicotine looks something like this. So what is in the nicotine? We have nitrogen, very obvious over here. We have the presence of nitrogen. Other than nitrogen, as I said, you have the presence of carbon in this ring. So that is all your carbon. The next element, carbon. The last but not least, we have the presence of hydrogen. And like we said just now, every carbon must have 4 bonds. As you can see over here, this carbon right now only having 3 bonds. 1, 2, 3. So this carbon will have 1 more hydrogen. This carbon also will have another hydrogen because it's only having 3 bonds at this moment. Same thing for this carbon, 1, 2, 3. So 1 more is hydrogen. This carbon right now having enough bond, as you can see over here. This carbon having 1, 2, 3, 4. This carbon already having 4 bonds, so it won't have any hydrogen. How about the other carbon in here? If you look at this carbon only having 1 bond, 2 bond, 3 bond. So this carbon have another hydrogen. How about this? This carbon over here having only 2 bond. 1, 2. So this carbon will have another 2 bond by right. So the 2 bond is the hydrogen. So bear that in mind, every carbon must have 4 bond. So the carbon that don't have enough bond will definitely be holding hydrogen. Can you see that? That is how we determine how many hydrogen the carbon is holding. So that is your nicotine. Next, we have aspirin. Aspirin is a type of painkiller. Alright? It works something like your paracetamol in the Panadol. So aspirin is another type of painkiller. And the structural formula of aspirin looks something like this. Obviously, you have the presence of oxygen as one of your elements over here. As you can clearly see, we also have the presence of carbon. So carbon is also another element. Last but not least, you can see the presence of hydrogen. So aspirin is made up by oxygen, carbon, and hydrogen. Next, we have coffee. So what is in the coffee? Caffeine. Caffeine is in the coffee or tea most of the time. And there's a lot more food or drinks that contain caffeine. And this is the structural formula of caffeine and what made up caffeine. As you can see, we have the presence of carbon. Next, we have the presence of hydrogen as the second element. We also have the presence of nitrogen in your caffeine. We have the presence of oxygen. Is there anything else? No, because you have the repetition of oxygen, nitrogen, carbon, and hydrogen only. So you have 4 elements that made up caffeine. Last but not least, we have DDT. The complete name of DDT is diphenyl-trichloroethane. DDT is a type of pesticide that we will use a lot in the farming to control the pests. And the structural formula of DDT is something like this. And obviously you can see over here you have the presence of carbon in the benzene ring. And also there is carbon over here. So the first element that you have is carbon. The second element that we can see, the presence of hydrogen, obviously. You can see the presence of hydrogen over here. The next element is the presence of oxygen. You can see you have the presence of oxygen over here. Next, you have nitrogen. Do you see nitrogen? We have nitrogen in the DDT. Last but not least, in the DDT, we also have the presence of sulfur. So, to make up DDT, we need the presence of 5 elements in a certain arrangement, which is carbon, hydrogen, oxygen, nitrogen, and sulfur. These are the elements present in DDT pesticide. And that is the way that we identify the type of element present in an organic compound. As long as you know the structural formula and able to draw out the structural formula correctly, you will then know what element present in that organic compound. Simple. Bear that in mind, elements are those things that you found in periodic table. Alright, so every box in your periodic table, that is an element. Thank you for watching for this short video. I hope this video warmed you up for the organic chemistry. I'll see you in the next video for more information about organic chemistry.